Hey, hi everyone. Welcome back again with a live stream session with Team Axiom. And agenda for today's live stream session is how we can design a DB structure, database structure, while implement the backend of any project. DB designs plays very vital role because the APIs what we develop as a backend at the same time the complete server side logical application is depends on the database structure we develop. So with Team Axiom, today we discussed how we can analyze, design, develop, and what are the possible ways we need to rethink on, analyze on, while defining the data structures of any project, DB structure of any project. What is the thought process behind it, and how we can finalize the database structure with various entity relationships and resolve the complexities. That is the motive of today's live stream. Just to understand what is database design is the process of structuring data in a way that is one, efficient, no duplicate data, fast queries need to be evaluated. Second, consistent data integrity need to be maintained. Third, scalable, can grow without breaking. You never know the limit of data you are accumulating, capturing, storing. So it can be a scalable, maintainable, easy for developers to understand and modify it. Because you are not the only one who is working on the project. There may be the group, there may be the team. So every table, every relationships, every entity relationships you are developing, it has to be well understood to everyone, and they can also in future able to modify it as per the requirement. Think of it like the architectural blueprint of a building. You don't put a concrete without a plan. You don't code without a database schema. So that is what exactly database design plays a role with. Why we need proper database designs? Because is it like creating few columns and the rows and the table in the database? And if we not organize it well, what will happen? It's not like we are just adding a data in the Excel sheet. It's a it's a relationship between many tables, right? So, and they all are interlinked. There is relationships between all these tables. So because of that, the proper database designs matters. The first thing achieve, what we can achieve by proper database design, that is data, we can reduce the data redundancy, duplicacy of data. For example, without good design, considering the real estate applications database in a view, if your designs are not good, database designs are not good, same buyer address can be stored in 5 tables. And if you update one, others will remain the same sort of, right? So if you don't have a design proper and the buyer's data you're storing, obviously with the different fields you're storing, but every table may be having the buyer's address, and if you are updating only one and rest remain the unupdatable or uneditable or non-changeable, right? So dynamic updates won't work. So duplicacy or will happen, or at the same time one person maybe have a different addresses may be found, right? With a good design, addresses stored once and referenced everywhere. I'm getting the point. So that is the good design means. Once update, every table wherever that references are need to be updated there and there only. That is what advantage of a good design means. The second advantage what we get by the proper database designs, that is data inconsistency. You can remove that. As I told you, the consistency has to be the solution. Let's say, for example, without a good design, a property shows as active in one report and sold in another. Take a reference of a real estate database. A property which you are listing is showing somewhere active, means it is available, and in another report it is shown as a sold. Now look at the reactions probably comes from the buyer. He might show the interest in the property, and then he found that it's already sold. So obviously he will get frustrated because of your database structures and all, because he never knows he's interacting with the applications through UI. He's not knowing what internally is happening. So good database designs is a single source of truth for status. Let's say, for example, in your railway reservation systems or any reservation systems, if the seats are viewing available and whenever you try to book them, just understand the frustrations of years if it is showing it's booked, right? So that data inconsistency you can able to overcome with the good designs. Next one is update anomalies. Without good designs, changing a buyer's phone requires updating 10 rows. Right? If you want to update just like the phone number of the buyer, but if your bad database designs requires 10 rows to be updated, it's frustrating. It's not a good design. Rather, the good database designs, one row updates propagates automatically, right? This one update, it has to update everywhere. At the same time, whatever the references are there, it needs to be updated immediately and instantly. Right? The next one is insertion anomalies. Can't add a new city without adding property first. Obviously, with the good designs, independent tables allow independent inserts. Deletion anomalies. Deleting the last property in Mumbai also deletes Mumbai from the system, right? So that is bad design. City that survives property deletions. You see, for one property you want to delete for some reasons, it should not delete the entire other things as well. Deletion anomalies. Query performance, because database we are designing to ask many queries, to process it faster. Why the table relationships are there? If there is a one table, probably we can manage the data in the Excel sheet. We can make a sort. We can add the filters. But this is not the case in the projects. We are dealing with thousands of tables. We are dealing with a lot of relationships. Just try and understand one point. If you go to the retail shop and you scan one product and it adds into the bill, but believe me, to have these transactions, it may need to go through that query need to be go through the 35 tables, maybe inventory, maybe like the stock availability, the price updates, everything. Maybe it has to go to 35 tables. So for one transactions, if a query has to refer 35 tables, don't you think so? It takes a lot of time to process. But with the good designs, the smaller index tables queries are fast, and it has to be updated on the runtime. You can understand that if your bad database designs consists these all the anomalies, what is going to happen? So because of these all the complexities, what we may get in the while dealing with the projects, a good backend developer need to focus on the better approach. It has to be well analyzed. You have to well define the various fields, the types of the fields, the table, the relationships, the primary key, foreign keys, the relationships, and it has to be well defined, and uh, we can able to view it in the entity relationship in a good manner, in a better manner, so that everyone can understand it. And this is what exactly the purpose of today's training. With Team Axiom, we're going to analyze all the complexities, whatever we'll be getting during database designs. And today's stream, my team or our team will help you all to understand how we can define the good DB structure and resolve that all complexities what I just discussed. Over to Team Axiom.
Welcome everyone. Today I will be presenting database design decoded, tables, relationship and normalization. Databases are the heart of almost every modern application. Whether it is an e-commerce platform, a CRM system, a banking application or a social media platform. A well-designed database helps store information efficiently, maintain data consistency, and improve application performance. In this session, we will explore what database design is, why it is important, how tables and relationships work, and how normalization helps create efficient and scalable database. Let's begin by understanding what database design is. Database design is the process of organizing and structuring data in a way that make it easy to store, manage, and retrieve. A good database design ensures data accuracy, reduce duplication, and support future growth. Whether it is student management system, an e-commerce platform, or a CRM application, every successful software system relies on a strong database foundation. Now, the question is why database design important? Without proper design, database can quickly become difficult to manage. Poorly designed database often lead to duplicate record, inconsistent information, slow query performance, and maintenance challenges. A well-designed database improves data integrity, enhance performance, support scalability, and simplifies reporting and analytics. In short, Good database design saves both time and resources in the long run. Before building a database, we need to understand tables. A table is the basic building block of database. It stores information in row and columns, where each row represents a record and each column represents a specific attribute. For example, in a student table, we may store information such as student ID, name, email, and course. Table help organize related information in a structured and meaningful way. Now, let's talk about keys, which are essential for database management. A primary key uniquely identifies each record within a table and ensures that duplicate record cannot exist. A foreign key is used to create relationship between different tables. For example, a student ID in the student table can be referenced in an enrollment table to connect student with their enrollment. This key help maintain data accuracy and establish connection between related information. Once tables are created, they need to be connected through relationship. Relationship define how data in one table relate to data in another table. There are three common types of relationship. One to one, where one record is connected to one other record. One to many, where one record can be linked to multiple records, and many to many, where multiple records can be connected to multiple records through a bridge table. Relationship help eliminate unnecessary duplication and improve data organization. Let's look at the practical relationship example. In a student management system, students enroll in courses. A single student can enroll in multiple courses, and a single course can have many students. To manage this relationship, we use an enrollment table that acts as a bridge between student and courses. This structure keeps the database organized while maintaining flexibility and scalability. Now, let's move one of the most important concept in database design, which is normalization. Normalization is the process of organizing data to reduce redundancy and improve consistency. The goal is simple: store data only once and reference it whenever needed. By applying normalization, database become easier to maintain, more efficient, and less prone to errors. The first step in normalization is first normal form, or 1NF. The main rule of 1NF is that each column should contain only a single value and each row should be unique. For example, instead of storing multiple courses in a single field, we create separate rows for each courses. This makes the data easier to manage and query. Next come second normal form, or 2NF. To achieve 2NF, the database must already satisfy 1NF. The goal here is to remove partial dependencies by separating related information into different tables. For example, instead of storing student and course information together, we create separate students, courses, and enrollment tables. This reduces duplication and improve maintainability. The next stage is third normal form, or 3NF. In 3NF, we remove transitive dependencies, meaning that non-key attributes should depend only on the primary key. For example, department information should be stored in a separate department table rather than repeatedly storing it with every student record. This further improves consistency and reduces redundant data. Now, let's look at the key feature and benefits of proper database design. A well-designed database provides structured data organization, relationship management, data integrity, reduced redundancy, and scalable architecture. These features result in faster data retrieval, improved consistency, easier maintenance, better security, reduced storage, uses, and simplified reporting. Overall, good design directly contribute to better application performance. Let's understand this with a real-world e-commerce database example. In an online shopping application, we typically have separate table for customers, product, orders, order item, and payments. A customer places an order, and an order contains multiple order items, and each order item references a specific product. Payments are linked to order to track transaction. By separating data into related table and connecting them through relationship, the database remains organized and efficient. This approach enables faster queries, easier management, better scalability, and accurate reporting, even when handling thousands of customers and transactions. Let's discuss some of the major advantages of proper database design. For businesses, it improves data quality, reporting capabilities, scalability, and operational efficiency. For developers, it simplifies development, maintenance, debugging, and future enhancement. And for end users, it delivers faster application performance, accurate information, and a better overall user experience. A strong database design benefits everyone involved. Now, let's look at the business impact. Organizations that invest in a proper database design experience improved system reliability, better performance, fewer data errors, and lower maintenance cost. They can also scale their application more easily as their customer base growth. For example, a proper normalized CRM database can efficiently manage thousands of customers and transactions without suffering from duplication or performance issue. To build an effective database, it's important to follow some best practices. Clearly define entities and relationships. Use meaningful table names. Create appropriate primary and foreign key. Av- Avoid duplicate data and apply normalization where necessary. Use indexing for frequently searched column and always design with scalability in mind. Following these practices helps create databases that are reliable and future ready. In conclusion, database design is the foundation of every successful application. Table helps organize information, relationship connect data logically, and normalization ensures consistency while reducing redundancy. A well-designed database improves performance, scalability, maintainability, and overall system reliability. As the saying goes, a well-designed database is not just a storage system, it is backbone of every successful application. Thank you for all your time and attention. I hope this session provide a clear understanding of database design, tables, relationship, and normalization. We explored how data is organized, how tables are connected, and how normalization helps create efficient, scalable, and maintainable database. That was all about database design, decoded, tables, relationship, and normalization. Now, I would like to hand over to my teammate who will provide a practical demonstration and show how a database is designed in real time, including table creation, relationship, and normalization techniques used in real world example. Over to you.
Hello everyone and welcome back to Team Axiom. First, I will share my screen. Hope my screen is visible to you all. This was the Power BI tool where we are explaining and demonstrating the relationship of tables with each other. First, I will just start with this points what we are doing today. In this session is all about database design, decoded tables, relationship, and normalization. Instead of learning database concept using simple student examples, we are going to design a real-world property match recommendation system. Now, This is similar to the recommendation engine used by real estate platforms, right? So we will learn how to identify entities, the create relationships, normalize data, and finally see how the same design is implemented using Prisma ORM and connected to the backend APIs through Postman, their documentation. Now let's get started. We have the agenda, understanding the business problem, system workflow, ER diagrams, database tables, primary key and foreign key, relationships, sample database using Excel, these kind of samples we have in the example. As an example, we have Power BI for the relationship, we have the normalizations, and we have test cases of Postman APIs, which we created for the connections of this relationship in database in this video. So these are the point and agendas we are covering today. So we'll just go back to the Power BI with the relationship. And before going to explaining this thing, we'll just imagine a workflow, a system workflow, how it is going to work. Now, look, we have the buyer table, match score table, public notification. Then we have the public swipe action, public property, the public agent, property MAT and MATs. Look, so the how it is going to be work. For example, Rahul Sharma from Dream House Realty listed a new 3 BHK apartment in Pune. And then the buyer registered here to buy this property. Let's you can say John Fernandez registered with this budget 40 to 70 lakh of property, which is preferred city in Pune, and he preferred BH 2 BHK. Then each property is associated with multiple amenities, these properties, and there is a buyer table and match score table. So if that property is asking about the swimming pool, gym, parking, securities, then the buyer browses available properties and starts swiping, interested or skip. So that will be stored in this swipe action table. He will swipe for the interested or he will skip this property. Then our recommendation is in concept, compare the budget, city, BHK, and swipe behavior, and it calculates the compatibility score in the match score table. Then finally, the system generates a personalized notification like new property match found in the notification section. It will get the ID, is read, message type, and it will show the buyer ID also in this section. And it will directly show the new property match found, or it will show price drop in your preferred area. Now that we are understand the complete business flow, let's see how this stored inside the database. Now we have the ER diagram, which is in the for this ER diagram we have used the Power BI desktop. We have the all the listed tables over here. I'll just open these properties and data. So these are the tables which we have in this tool with this models. So we'll close it. We'll close the property and we'll just discuss about how it is going to be work and how the relationship of table columns are connected with each table for a single table. Now, instead of looking all at tables together, we divided into two categories of this table. First was the master table, this store permanent information. Like we have the agent table, then we have property table, then we have buyer table, and we at the last we have the amenity table. These four table are the master table of this data. We can say these tables rarely changes, and then we have the transactional tables which stores system activities. was like property amenity table. Then we have the swipe action table. Then we have match score table, and the last we have the notification table for the notifying this in this platform. These tables grow continuously as users interact with the application, and then we'll understand each table one by one. How is table is working here? So first we have the agent table that it stores the information about property agents or brokers. We have the columns with the agency name, creator, email ID, name, and the phone. Important columns we already see. We are seeing in this table section card. The one important thing is notice, which is one agent can list multiple properties. So we already have our first relationship, which is one agent, many properties, means one to many, right? Then we'll switch to property table. There, this is the heart of our application because it stores every property listed on the platform. Each property contains details like this property ID, title, description, then latitude, locality, pricing, status, the title, and if we scroll up, I'll have the agent ID, area square feet, BHK, city, and the created it. You will also notice an agent ID as I mentioned here. This is the foreign key that connects every property to its owner. Instead of storing the agent's name repeatedly for every property, we only store the agent ID here. This avoids duplicate information. As my team member already explained in the PPT section, so we'll see this in the realistic relationship. So first we use the foreign key agent ID from the agent table. Now we'll we'll switch to buyer table. Look, this stores buyer details along with their preferences. For example, John Fernandez wants budget 40 to 70 lakhs, as we have the example we discussed in the workflow. He wants to BHK in Pune. These preferences will later be used by our recommendation engine. But one buyer can swipe multiple properties, so it will receive a multiple notifications and receive multiple recommendations also. So for that, we have the table structure like the columns are BHK preferences, budget, max budget, and minimum budget. The city preferences, what city is going to prefer for this, the created ad. Then the email ID, name, and phone. ID is the primary ID, primary key of this table, of buyer table, and the name and phone number for these are the basic details of this buyer. Now we'll switch to amenities. Right? The last we have the amenity table. Instead of writing full gym, we have means repeatedly inside every property we have to add the column and details. That's why we create the master list with this included data. Like we'll store here the swimming pool, gym, garden, parking security. Each amenity has one unique amenity ID. That for that only we have created this amenity table. Category category column iron icon and the ID name. Then we have in the left side property amenity. And here we are just referring and we are showing the amenity ID and the property ID. This is called the junction table. We can say. Why do we need this? Because one property can have many amenities, as we already discussed, and one amenity can belong to many properties. So this creates some many to many relationship. As in the previous session, we discussed about the one to many, and now we'll discuss about the many to many. So that's why we created the both tables separately. One is the amenity table, and the one is the property amenity, which is showing the many-to-many relationship. So instead of storing pool, gym, parking inside one cell, as we discussed, we created separate rows here. And this is perfect example for good database design. And this is needed for the relationship. Then we switch to swipe action here. This table records buyer behavior, and whenever a buyer swipes, interested or skip, a record is inserted here. With this information later becomes the input for our recommendation using this table. Now, but where it will show the users it is match or not. So that's why we have the match score table. And once the buyer has interested with the property, a recommendation engine calculates compatibility for every buyer property pair, and a score is generated. Like example, we have buyer 201 suggest to property 101, and it matches the 97.5% of matching score. So this score is calculated using budget, city, here the score property adding calculated. It will calculate as budget, city, BHK, and the swipe behavior, which is calculated in the swipe action table. Now, where is going to be notify? So that's why we created the notification table, where the notification table shows alerts sent to the buyers. Example, we have new match found, price drop, new property available. This kind of notification is going to be stored here and will appear to the buyer, sent from buyer or to the agent. But probably this is for the buyer because it every end notification goes to the buyer as he wants the recommendation on, and it all the notification belongs to the buyer only. Now this is the relationship and the table explanation we discuss here. Now we'll switch to the Excel where also we have the relationship with the primary key and the foreign key for a particular table. And this table relationship we created here in simple way by using Excel sheet. So in the top second cell, you can see that we have the primary key with this color and the foreign key with the light pink color. These both different colors is showing the availability of keys of primary keys and foreign keys in the particular table. Look, there's a in the notification table we have the first primary key is notification ID, and the second we use the buyer ID as a foreign key from the buyer table. So we are have the relation flow buyer table is sending buyer ID as a foreign key to the notification. Like the buyer ID also referring to the swipe action. As here we can see that this buyer ID is used as a foreign key in the swipe action. Same, this buyer ID is also referring to the match score where we are showing the relationship. Means the buyer in the buyer table, buyer ID is the primary key for this table, and it is foreign key for the these different tables: notification, swipe action, and match score. Same, we can see the swipe action table where we have the swipe ID as a foreign ID. So, sorry, swipe ID is the primary key in this section, but buyer ID and property is the foreign key in this swipe action table. So it comes from the buyer, and it this is come from the property to here. This is the relationship we explain here. Now we'll switch to the property table. Here we also have the property ID as the primary key, and the agent ID is the foreign key. So where it comes from? It is come from the agent table. In the agent table, we have the agent ID as a primary key, and we use this agent ID as a foreign key into the property table. Same, we refer the property ID to the property amenity. as a foreign key, and we'll switch to match score. We discussed notification, swipe action, buyer, property, agent. We will switch to match score. In the match score, we are having the match ID as a primary key, but we uses the foreign keys from buyer ID and the property ID in this table because this both requires for this match score. So we store these keys into the match score for referring, and it is unique, which helps us to structure the database in better way for the our application platform, right? So we'll go again the remaining for the property entities and amenities. So the property ID is referring to the property amenity table as a foreign key where we use the property ID, and then we have the amenity table. In this amenity table, we have the amenity ID as a primary key, which is used as a foreign key into the property amenity table. So this is the table relationship for the particular primary key and foreign key we discussed here. Now we'll switch uh, the structure, database structure. Let's switch with this realistic sample data in the Excel and see how this table looks with the actual sample data. Since our database is currently in design phase, so I'm using realistic sample data to demonstrate relationship. The structure remains exactly the same as our real database as we have. Now, in this sheet, you can see in the multiple sheets we have multiple tabs we have in this sheet. These are belongs to the database tables, as we can say that agent, property, buyer, MAT, property MAT, swipe action, match score, notification, and in the last we discussed the table relation is similar for the primary key and the foreign key. Now we'll we'll discuss and we'll explain the each and every table with the sample data. As in the till now we explain and we have the um, thought in mind as relationships, how relationship is working. But in the really that sample data we have to see that it is really working or not. We discuss the relationship, table relationship, the workflow, and the ER diagram, how it's going to work there. Now we'll have the relationship demonstration with the sample data. Let's we have the tables together, and first we have the agent sheet. And agent sheet we have the list of sample data with the column agent ID, name, email, phone, agency name, and we have the created at with the number of IDs, and every ID has the referring name of the agents. Now, we have an example like look in the five agent ID 5, we have Vikram Mehta as an agent. So we'll go with this flow. We have the agent ID 5. Now we'll check this agent belongs to which properties. So we'll switch to property table and notice that multiple properties have agent ID 5. You cannot able to see, but there's a multiple properties is listed here with the property ID 101 to till 135, and list of titles are available here: 2 BHK modern apartment, luxury villa, and all things with the description. We have the price column BHK. This belongs to 2 BHK, 4 BHK, 1 BHK, area, square feet, city, locality, latitude, longitude, status, agent ID, and created. But here the table is referring, and which is more important, which is the agent ID, because we'll see here which agent ID is referring to the which property, and which property belongs to which ID. It's the connection and the relationship. And in the status, we have the available status, sold and rented. So as we collected the ID of 5 of agent 5, so we'll just filter out, we'll unselect all and we'll click on the 5 as we want the agent ID of 5 belongs to which properties. So list here we have the four properties which is belongs to the agent ID 5. Here you can see the 555 is belongs to this 105 property, 115, 125, 135 with the penthouse, 3 BHK apartment, 3 BHK flat, 3 BHK apartment with the description and pricing rate, and the location is Mumbai, Pune, and the locality also. So this tell us one agent with many properties, and this is the one-to-many relationship, right? Now we'll switch to buyer. We have the buyer sheet. There's a multiple columns and sample data we have. We'll discuss buyer ID column we have. Then we have the name of this buyer. Then we have email, phone, budget, his budget regarding minimum budget to maximum budget ratio. Then he have the BHK preferences. He wants 2 BHK, 3 BHK, 1 BHK. Then he have the preferences city, Pune. This all the columns are same as it is we discussed in prior in the database relationship. So these are the same columns and the created at. So we'll discuss about 2201 first. This was the first buyer, John Fernandez, as we discussed. He wants minimum budget. He had a minimum budget and maximum with this 2 BHK preferred and city is Pune. As in the prior we discussed about this example, so we'll go with the sample data only. Now that means one buyer, many swipe actions, right? So look at the property amenity. These are the name of the buyer with ID. So we'll go the property amenity and we'll see the property amenity 101 is same till the 8 counts, but which changes with the MET ID 1, 2, 3, 5, 6, 7, 10 till 101 means one property 101 is belongs to many METs 1, 2, 3, 5. Instead of writing everything in one column, we created multiple rows. This creates a many to many relationship using junction table. Right. So these four tables we discussed, and we these property ideas we say that here the property amenity table. Now we have the sample data with this kind of Excel sheet, and the relationship we discussed, table relationship we discussed, the notification and match score. But we discussed about the four tables. Now we'll go with this remaining tables. Till buyer we discuss. We'll go to the amenities. We check we have the MET column with the MET names, category, and icons. This table shows all the available amenities. Like we have the example number of MET IDs with the MET name, swimming pool, gymnasium, covered parking, garden, lift, so many. Each MET has a unique ID is showing here. And for example, while example, we switch direct buyer to the property MET. So this is the property can have multiple amenities as we discussed, and one amenity can belongs to multiple properties. This is related to many relationship. So we created that separate mapping table. Now we'll discuss about the sample data regarding swipe action. Right. In this swipe action sample database, we have swipe IDs. Then we have the foreign keys of buyer ID and property. Look, we have first row with this swipe ID is 1. Then we have the buyer ID 201. Just go back to the buyer table and 201 is the John Fernandez. Right. So first buyer is this. He swiped some more properties and he switched he interested in three properties. Like you can see that this 1, 2, 3 buyer ID is same means the one buyer is matched with this property similar to 1, 2, 3, like 101, 104, 133. with the match score 97.5, 95.2, and 92.8 match score he got for the three properties from the John Fernandez is the buyer. And this recommendation and this match score we have. So it shows that and it scores the calculated using as similar he preferred budget city BHK buyer preferences and swipe history. Now we'll go to the notification sample data. Here we have the columns as we discussed notification, buyer ID, messages, type is read or created at. Then new match will appear like this was the message notification for this for the 201 which is John Fernandez. Message was a new 2 BHK apartment in banner match your preferences and type was match found. Is read or not, the status is showing here false, false, read, created at. Same for the other buyers also. We have the listed sample data, more sample data with the more messages. Every message will be dropped by using agent to the buyer for the buyer only because we are recommending properties to the buyer only. So these are the table relationship. We just will give a small brief. Like now we have agent goes to property, then one agent to many properties, then buyer to swipe, buyer goes swipe the properties he wants, interested or not. So that they have the many swipes, and then again the swipe goes to the one property, many swipes. This match score will be belongs to the many recommendations and all the other things goes and sends notification. Then one buyer, many notifications, and property goes to the amenity. This shows the many to many using property amenity relationship. And by for this we use the primary key and foreign key while pointing this all the relations. Right. Now now after that we have the normalizations. What is normalization? We have to clarify this point. One enough, two enough, and three enough, which is third enough. And how it's going to relate this example in this properties section. So first thing is 1NF is the first normal form, and the rule is already explained by the team member, which is I'll just remind you every column should contain only one value, which is atomic value. Second was the no multiple values in one cell. These are the cells, we can say that, and this is the best thing to explain here. Then no repeating groups. So we'll as we comes to property amenity table and property table. These two tables will explain a good example to us. Now, first we have the property sheet, and in this, what suppose I store all amenities directly inside the property table. Just imagine that thing. Property 101 ID have the 2 BHK modern apartment, and they have the multiple amenities, right? Pool, gym, parking. Then this is not the first normal form because one column contains multiple values. If 101 property ID belongs to multiple amenities, 101 is from this to this. This belongs to the multiple amenities from 1 to 10. Means this is not the first normal form, and because one column contains multiple values, so this was a not reliable thing. Now we'll switch to property amenity sheet and we'll have this uh, data which we discussed. Instead of storing all amenities inside one column, every amenity is stored in the separated rows. Every cell contains only one value and this follows first normal form, which is this. This is the best real example from a workbook as a sample data for the 1NF as a first normal form, right? Now we'll switch to the 2NF, which is second normal form. And that rule is must already satisfy 1NF as we discuss and see the example. Then the no partial dependencies. So for that, we need a property amenity table, and this sheet specifically designed for the 2NF only. Here we have the property ID and amenity ID. And this table only stores the relationships. Now, should not be here. Like what should is missing here? Property ID, amenity ID, property title, amenity name. Like we in the private the example about 101 is the property, one is belongs to the one amenity, and the property title is from this amenity is like swimming pools, gymnasium, anything, and the buyer wants the luxury villa also. So property title depends on property ID. Amenity name depends only on the amenity ID, and they do not depend on the complete key. Here you can see that. Therefore, this violates second form, nor second normal form is uh, explains here, and with relates to this example, which is I'll just give a brief, small brief to you. Property amenity contains only property ID and amenity ID, nothing else. Then the property sheet, the property sheet contains property titles. This is showing here, and amenity sheet. This sheet is belong and contains amenity names. We separated the information into master table, and this removes partial dependency and satisfied second normal form in this table. In this table, here we satisfied with the 1NF into 2NF. So we have this example relatable in this topic. Now we'll switch to the 3NF, which is the third normal form. And before going to the example, we have the rules. As discussed in the team, we will remind this. No transitive dependencies needed, and every non-key attributes depends only on a primary key. Primary key, foreign key, we know about. We everything small basic things we discussed about the primary key and foreign key in the table relationship for this data, sample data. Now, for this, we need a property table again because everything is dependent on the property buyer agent and this entities. So these are your strongest example like this. One property sheet shows the columns, this columns, every column, and here in this column, are you seeing any agent name in this table? There is no agent name. That's why we use the agent ID, not the name of agents, but we use the agent ID. And then we switch to the agent table. We have the entire detail of an agent by using agent ID, name, email, phone, the agency name, and created it. But basically, this all the details which is stored in the agent table is not in the property table. Just we referring a agent ID. Understand? Hope you understand going what I am going to say. Property table stores only agent ID. All agent information stays in agent table. This is the references which is helps you to structure the database and give a better table relationship in the database structure for your platform. And if you stored agent name, phone, agency name inside property table, so inside property table, every property listed by the same agent would duplicate that information. Like there will be like, if imagine there will be just four column new added, and the repeatable data will be shown here. When wherever the one is repeated, there will be the name will be going to repeat, and one is here, 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 every time. So the multiple and duplicate data will be shown there. The phone number changes, you would have to update every property row here. That's called transitive dependencies. By moving agent information into a separate agent table, our design satisfies third normal form. That's why we separated the agent table in the separate form, and whatever we want to update, we can update here only. By using the ID, agent ID, we can refer to the properties, and the workflow will be remain safe, secure, and structured way for this platform. Right? We discuss about the 1F, 1NF, 2NF, 3NF in brief with the example. We'll just summarize the table. What we did. We have the normal forms 1NF, 2NF, 3NF. In the Excel sheet, we discussed for the 1NF is the property one table and property table and property amenity table. With the 101 multiple amenities. We have the property 101 with the multiple amenities. And one value per cell amenities moved a property amenities, as we already explained in this first example. This second 2NF. In this 2NF, we have the property amenity table, then we have the property table, then we have the amenity table. The three is table. By using these Excel sheets of three, we we explain the composite key, property ID, amenity ID, amenity ID, property ID in this table. And property title and amenity name belongs to their own master tables, as they are the own master tables. Then third 3NF is the property and agent, like agent table and the property agent, property table. Here we use the agent ID in the property and agent detail in agent table. These properties stores only agent ID, and agent details stays in agent table to remove transitive dependencies, to the safe structure of this, no duplications in this property table. So this is the discussion points on this. We'll just summarize the ER diagram for the relationship. Then in the Excel sheet, we about table relationship. Again, again, this was a thing we already discussed, but I'll just you walk you through a small brief. We have the parent tables as we have agent, buyer, property, buyer, then property, buyer, property, images, these things. With the child tables also, agent, property, then buyer to swipe action, property to swipe action, these are things. But just imagine the first row, what is showing. Parent table is agent and its child table is property. So what relationship is goes? One to number of. The property is using the foreign key for agent ID and agent dot agent ID. It explains one agent can list many properties. Similar thing happens with the buyer to swipe action. There is a relationship one to n, and it uses the foreign key as a buyer ID, buyer dot buyer ID, and one buyer can swipe many properties. Similarly, we have the all the details with this table for giving a small and small brief to you. As we already discussed about all the things, but these are the data which helps to understand more in deeply. Right. So these was the things we discussed in the today's session. Now we'll switch to the Prisma schema. We discussed about all the relationship data, Excel sheet, everything. Now we'll switch how the data is imported and what we use for here. So we use a Prisma schema for the PostgreSQL, and this is schema we have for the generator client provider. We have the Prisma client JS file. Then we have the data sources DB for the provider. We use PostgreSQL. These are the variables for the database URL. Then we have the enum property status, available, stored, and rented. Then we have the swipe type, where interested or skip. Then these are the queries and structured which uses for the creating the database in PostgreSQL using Prisma, schema.prisma. These are the schema which need, and this is everything whatever we discussed till now with the example. This is the real database configuration we are going to use here, and this was the way structured code. And then we have the notification types with the match found, new property, price draw. Then we have the model, the buyer. Here is the main thing starts. These are the column names with the with the type. The ID is belongs to the int, and here's the at the rate ID says that default auto increment. Whatever we know about the SQLs and everything. So these were the format syntax for the PostgreSQL we use. These are the column names, and this in the second column is showing the type of this columns and with unique ID, as email is the unique part here. And then in the last section we referring swipe action as a swipe action array, match score, notifications. And the same thing with the agent. Then we have the property table. Here in the section we added the more things, like we added the relationships also. These are the common default for the status and created. Then we have the agent ID in the property table. Agent ID and agent. We uses the type, and here the main key is relationship. Means the relation word with the fields we uses the agent ID for referring ID. Means we are taking the foreign key as the agent ID from the agent table. These are the entities, same, and the same things happen with the empty tables. Then we have the property entity. Property entity is we discussed all the things like property ID and the entity ID is. So both the relation we have added here for the from property table and entity table. We added the relation. Which field we want? We want the property ID as a foreign key from this master tables, and we are referring the IDs from this table to here. Then we have the swipe action with the same we use here. This is the column, and till the end we have the all the table coded here with the references and relationships we use here as a coding, and we discuss the examples of these things. Now these are the structure, and although database is currently empty because the schema is fully prepared for this sample example data, and as follows, some follows the same design which we uh, discussed till now. And when data is inserted, it will populate these tables in this table. Will I will just show you how the table looks. Just a second, it will take time. We will go to the back end, and directly is open. We'll have to enter the Apex Prisma Studio, so it will open a PostgreSQL database structure where we have the all the tables of this platform is showing that. Look, so this is the interface of Prisma Studio, and this was the PostgreSQL where we have a current database, which is all the tables which is created, and everything we discuss as a sample data that will be going to be stored here in this section. As you can see, the first entry is here the from buyer table as the first ID Sahil Rangari with the email ID and mobile number. All the details which I added here is stored here. It's showing the match score, modifications, swipe action, and the amenities, these things. So whatever we discuss in the sample data of Excel will be going to be continuously same as it is in this database. Yeah. And how it is going to work. So we check with the schema, we discuss the relationship. I will give use the some guideline about property image recommendation system with API testing documentation. These are the API testing documentation and how is working. Like we have the first endpoint for the create agent. Now we use the endpoint, which the method is post, and we will add this endpoint to the postman. We have to add the request body. Whatever the agent, we have to enter there. This type of interface will be open in the postman. We use the postman. We can use anything. Similar, we have the create wire also with the endpoint, then body with the screenshot for how it looks, and we have to click on the send button. Just okay, right. So similarly, we have the create property also with the endpoints and the request body. What we have to add, we can add manually as per requirement. Then we have the amities for the properties. We added the 1, 2, 3 only here. With this endpoint, we have the API slash properties one and the amities. Then we have the create property endpoint. So here's the request body. We have to add the title. We added 3 BHK villa. Then we can add a description luxury villa in Pune. We have to add the price range, the BHK we want 3, 4, 5, the area square feet, how much area we want for this property, in which city we want. We can add here the locality and the agent ID will be referring to. That will work the while the platform is work. Then we have the add entities to properties. That entities will be going to be add in the property section. This is the property swipe property endpoint with the swipes and what we required in the request body we want a buyer ID and property ID and the action is interested or swipe the two. Then we have the calculate match for the match score. So this was the endpoint, but we added here the post method with the endpoint is slash calculate. And in the request body, we have to pass ID of a buyer and the property ID. For this kind of interface will have. In the last, we have the create notification. It will be created by defaultly. We created this endpoints only. API slash notification. It will work automatically when the other things will work. And this is the testing area only I am sharing with you. So this was the test cases and we discussed here. Now, now the final real world example I'll give. Just we discussed about the John Fernandez for the budget of 40-70 lakh. So this was the relatable to this platform, and we can check and find the properties by using this flow. And we have uh, a good discussion and description on this database relationships and table relationships. Now we explored how real-world property match recommendation system the from understanding the business workflow and the database designs to relationships. Then we discuss the normalizations. Then we have the Prisma schemas and the API integration, all the things. This is the same approach we use in the production also. This was Now, let's check with the today's uh, explored topics which we discussed. We discussed real world property. We have the mass recommendation system in this design. From understanding the business workflow, database design to relationship normalization, Prisma schema, and the API integrations. This is the same approach used in production application before development begins. So these all the things we discussed today is going to be a part of production things, and before production the requirement of these things. Now with that I would now like to invite a director to share his valuable guidance and insight on the topic. Over to you, sir. Thank you.
Hey, thanks, Team Axiom. You did a fabulous job to explain us why it is important to have a good DB structure, as well as how we can, by taking an example of a real estate database of applications, you guys give us the brief guidelines and in detail analysis and how we can develop a data structures, set up interrelationships, and many more. I hope through these sessions, uh, the attendees must understand uh, the importance of creating good database structures before producing any APIs, right from the analysis to developing and setting up the interrelationships. Everything might be clear to the audience. I hope uh, you will be get you will be get all the clarity about this DB structure development. To have some more topics like this, do join us, comment us, as well as subscribe us so that like together we can discuss many such technical topics so that we all can upskill ourselves to serve the industry better. Have a good day, guys. Thank you.
In Axiom Tech Guru, we transform ideas into scalable digital solutions with AI, innovation, and technology that drives real business growth.